Chapter 4 of AI, a modern approach by Stuart Russell and Peter Norvig, focuses on beyond classical search. It expands the decision of search strategies to include more sophisticated techniques for handling complex, dynamic, or infinite environments, as well as optimization problems where a straightforward search may not be feasible. First, local search algorithms and optimization problems. Local search algorithms are introduced as an alternative to systemic search strategies, particularly used for problems where the goal is to find an optimal solution rather than a path. These algorithms do not explore the entire search space but instead operate on a single current state and move to neighboring states to improve the solution. First, hill climb search. This is a simple algorithm that continuously moves towards states with a higher value in the hope of finding a peak. However, it can get stuck in local maxima, plateaus, or ridges, making it ineffective for finding global optima. Simulated annealing, inspired by the physical process of annealing in metallurgy, this algorithm allows occasional moves to worse states in the hope of escaping local maxima. The probability of making a move to a worse state decreases over time, stimulating the coding process. Local beam search. Instead of keeping a single state, local beam search maintains a state of k values and generates successors for all of them. The best k successors are then selected for the next iteration. This method reduces the chance of getting stuck in local optima but can suffer from a lack of diversity if all states converges too quickly to similar regions. Genetic algorithm. These are inspired by the process of natural selection and operate using a population of candidate solutions which evolve over generations. Genetic algorithm apply crossover and mutation operators to create new offspring, favoring the survival of the fittest solution. These algorithms are often used in optimization problems where the solution space is large or infinite and exhaustive search is impractical. Second, local search in continuous spaces. The chapter extends local search algorithms to continuous state space where solutions can take any real number value rather being limited to discrete steps, such as gradient descent. This method involves following the gradient of a cost function to find a minimum. It is similar to hill climbing but operates in a continuous space. Stochastic hill climbing. This variation chooses at random among the uphill moves to avoid bias in the direction of steepest ascent. Newton's method. This advanced technique used second derivatives to find local optima more effectively, especially in the functions with well-behaved gradients. Handling continuous spaces requires special techniques for approximating gradients and determining step sizes to navigate the solution landscape effectively. Searching with non-deterministic actions. The chapter then addresses search strategies for environment where the outcomes of actions are uncertain. In such cases, actions might lead to different possible results, and the goal is to find strategies that achieve the best possible outcome. Contingency planning, also known as and or search, involves searching for plans that specify what actions to take depending on the outcomes of the previous actions. It handles uncertainty by including conditional actions in the plan. Exploring belief states. When an agent doesn't know the exact state of the environment, it can reason about a belief state, a set of possible world states. The agent uses these belief states to make decisions that maximize the chance of success. The authors describe how to adapt search algorithms to operate over belief states and final solutions that account for uncertainty. Fourth, online search agent and unknown environments. In scenarios where the agent doesn't know the state space in advance, online search techniques are required. These agents need to learn about the environment as they explore. Online DFS and online BFS. Variations of traditional search methods adapted for unknown environments. They systematically explore nodes while keeping a track of visited states to avoid revisiting them unnecessarily. Learning real-time A star. This algorithm learns the cost to reach the goal dynamically while performing the search, making it suitable for unknown environment. It updates estimates of the cost function based on experience, gradually improving the search as more is learned about the space state. Online search methods are critical for applications like robot navigations and autonomous exploration, where agents must operate effectively despite incomplete knowledge. Optimization, problem, and constraint satisfaction. The chapter touches upon problems where finding a solution requires a satisfying set of constraints known as constraint satisfaction problems. CSPs are mathematical problems defined by variables. They must satisfy specific constraints. Examples include a map coloring problem, scheduling, and Sudoku. State representation for CSP. The state in a CSP is defined by the values assigned to the variables, and the solution is to complete assignment that satisfy all the constraints. Solving CSP using such techniques such as backtracking, search unreduced, where variables are assigned values one at a time, and consistency checks like forward checking and consistent propagation are used to prune the search space. CSP are relevant in many practical applications, including scheduling, planning, and resource allocation, where finding feasible solution efficiently is crucial. Now coming to conclusion, chapter 4 extends the classical search framework to handle more complex, dynamic and uncertain environments, as well as continuous and optimization problems. It introduces techniques for local search, handling non-deterministic action, online search, and constraint satisfaction, providing a robust toolkit for solving a wide range of AI problems. The chapter's exploration of advanced search techniques lays the foundation for understanding more sophisticated AI strategies and real-world applications where search plays a critical role. Thank you.